to simplify, right? Usually we would try to get rid of a denominator, but it doesn't always happen. But if that was our goal, was to get rid of the denominator, and you look at it, there's nothing you can replace 1 minus sine, right? We know based on our trig function, our Pythagorean, that sine squared plus cosine squared equals 1, but sine and 1 by itself cannot be replaced with cosine, right? You can't do it if it's not squared. So the last example that we did on, what day was that? 2 days ago, on Tuesday, 15 actually was kind of a hint to what you can do with these. So if I were to take and multiply by the opposite of my denominator, which would be 1 plus sine, right? If I did that in both the top and the bottom here, and I FOIL out the bottom, what do I get?
Sine squared x minus 1.
Other way around, right? 1 minus sine squared x, right? If I FOILed it out, that's what you'd end up with, 1, and then negative sine, and then positive sine, and then negative sine squared. That can be replaced, right? Like, what is 1 minus sine squared? This whole thing is cosine squared. So then I end up with cosine squared times 1 plus sine, because you'd have to multiply it in both the bottom and the top, times, over cosine squared x. Can I simplify that? Yeah. What would you do? Just cancel out your cosines. So that is a way to eliminate a denominator that is not a reciprocal function, that is not already part of your Pythagorean theorems, right? Like that's a way to eliminate when you can't do anything else, okay? You can literally multiply both the top and the bottom by the opposite in the bottom. If it's an expression, this is when you would want to do it, if it's a plus or minus, and then see if what the result is one of your Pythagorean identities, which is in this case, and then it simplifies it.
Why is it, for like the cosine squared, why is it 1 plus sine x? Shouldn't it be 1 minus?
For this, so when we multiply, to determine what you're multiplying by, you want to look at your denominator and you want to write the opposite, right? You're going to multiply by the opposite. But whatever you do the bottom, you have to do the top. You can't make them two different things. Because technically this is 1, right? So I can multiply anything by 1. Oh, so sine squared plus cosine squared equals 1. When I got 1 minus sine squared, you would move this to the other side. So cosine squared would equal 1 minus sine squared.
Yeah, but didn't you put 1 plus sine squared? Sine x?
For here?
For the thing next to the cosine.
So this multiplied out gives me this. Because it's the difference of two squares, right? If I actually distribute that, if I did 1 minus sine x, and 1 plus sine x, and I FOILed it out. This would be 1 plus sine x minus sine x minus sine squared x, and then these cancel. So that is what the bottom gets replaced with. That's what the result of this is.
So then how did you get it to?
So then I went up to my Pythagorean identities, and I said, if 1 minus sine is on one side, how do I get there? I'd subtract sine squared from both sides, and I end up with cosine squared equals 1 minus sine squared. So 1 minus sine squared can get replaced with cosine squared. So the hardest part of those, and I would say start to write out your Pythagorean identities as many times as you need to in order to learn them. The hardest part of them is if it's not what's already there, how do I manipulate it to get it there? So if you see a tangent with a 1 or a tangent with a secant, and they're squared, tangent squared with 1 or tangent squared with secant squared, you're going to go to your Pythagorean identities and you're going to try to figure out which one you can use and how to use it. So as soon as you see that 1 minus sine squared, I'd go to Pythagorean identities and see if I can manipulate that one to get it to that. You could see cofunctions on your quiz. Yeah, which would be just in the replacement. I think there's some in today's notes. If not, we'll definitely pull one in. Yeah.
What about the even odd?
Same thing. So you'll see them, and those are the ones that you want to look. If you have a negative on an angle, go to your even odd. If you see pi over 2 minus an angle, go to your cofunctions, right? Like those are the ones that you're going to see. And honestly, they look scarier than I think that they are. It's just straight out replacement. But I think that there's, if I'm not wrong, I think there's some built into today's notes, and if not, I will add some in. Okay.
So we have to memorize it.
Yeah. You know half of it already.
Yeah, but it's on
You do.
Monday.
Huh?
It's on Monday.
Which means you have from now until then to memorize that whole thing.
It's on Mondays.
Well, make that not happen this week. Yeah. What? Quiz 7172.
I kind of regret not dropping quiz grade last quarter. Well, we should just kept it.
Oh, these are my suggestions all the time. I should have Ms. Carver. These two come up with the suggestions, and I say thank you for sharing. And then, but it's usually those two. And I mean, everybody appreciates the suggestion. Yeah. Yeah.
They could put it in the suggestion.
I tell them that is, look, that's where my suggestion bin is. It's also my complaint collector. Yep. I didn't record any of that. This is our reference sheet again. If it's sine of negative x, then it's the same thing as saying negative sine of x. If it says tangent of negative x, it's the same thing as saying negative tangent of x. Cosine is the one where it goes away. So if you're building, like if in your original statement you see something that says cosine negative theta or cosine negative x, you could actually just replace it with cosine of x. That's all straight substitution. You don't have to do anything else with that. And then their reciprocal functions follow suit. So like if I had cosecant negative x, I would replace it with negative cosecant x. If I had cotangent negative x, I would replace it with negative cotangent x. And if I had secant negative x, I replace it with a positive secant x. So cosine and secant are even functions. Even if it's negative, it will go back to the original, where the other two are odd. If it's negative an angle, that negative gets bumped to the front, okay? And then the co-functions, you're looking for this expression somewhere. You're looking for pi over 2 minus an angle, pi over 2 minus x, pi over 2 minus theta, pi over 2 minus u. That's the same thing, okay? And remember, sine goes with cosine. So I replace sine of pi over 2 minus theta with cosine of theta because those are complementary functions, okay? And tangent goes with cotangent, secant goes with cosecant. And then the reciprocal is the reverse of that. So cosine will get replaced with sine, tangent, cotangent with tangent, and cosecant with secant. Oh, some just tips. Again, this is like one of the hardest things to teach because I can't tell you do step 1, step 2, step 3, okay? But usually you're going to be working with the more complicated side first. So if you've got a multiple part on the left side and you've got one trig function on the right, obviously you're going to work on the left-hand side because you're not changing that one trig function, okay? But at least you have a goal in mind now. At least you know when you got to the end, okay? There could be factoring like we did on 7-1 where you might have to factor out your expression, okay? A lot of times you are taking things that are in your reciprocal functions and you are rewriting them in terms of sine and cosine. So tangents get rewritten in terms of kinds of sines and cosines, that kind of stuff. And obviously your Pythagorean identities. If I see squareds on functions, I tend to look for my Pythagorean identities. So if it's sine squared with either cosine squared or sine squared with 1, I'm going to my Pythagorean identities. If it's tangent squared with 1 or tangent squared with secant squared, I'm going to my Pythagorean identities. And then cotangent with 1 or cotangent with cosecant squared, I go back to those Pythagorean identities and see if I can manipulate them to replace it.
So this lesson's pretty much it gives you the end result.
Exactly, which I think is easier because you know where you're going. It's like having a goal in sight, right? It's easier.
Both those lessons are saying exactly just one shows what the end result.
Right. Yeah. All right, so here, let's work. We're literally just going to work through a bunch of examples. So this first one says secant squared x minus 1 over secant squared equals sine squared. So obviously, what side are you working on? The left side, okay? What do you see there that is like a hint to go somewhere on your reference sheet? Secant squared and 1, okay? So if you go to your reference sheet, what's the trig identity that has secant squared and 1? No. Tan squared plus 1 equals secant squared. Yeah.
It's a weird question, but if you're doing that, can you multiply by -1 to get what you want or no?
Yeah.
So if you usually like
So I don't need to this time, right? I can just subtract the 1. But you're saying if those were opposite signs, yeah.
you would multiply that
Yeah, because you could technically just move it to the other side. It's the same thing. Yep. So tan squared would equal secant squared minus 1, which means secant squared x minus 1 can get replaced with what? Tangent squared. I still want it to equal sine squared though. So what? You can move secant to the top, and if I move from the bottom to the top or top to the bottom, it becomes what? Good, it's reciprocal function, so this would be cosine. So cosine squared x times tangent squared x. Then what? Yeah, so if I wanted to, I could make secant 1 over cosine in the bottom, and then I could go through the keep, change, flip process. But the shortcut with those are if you are moving a trig function from the top to the bottom or the bottom to top, it becomes its reciprocal. So like if I had done it, which I probably wouldn't have, but if I had moved tangent from the top to the bottom, it becomes cotangent squared. Secant moved from the bottom to the top becomes cosine squared. Richard.
That's secant squared equal to tan squared plus 1 and then cancel out the tangent?
No, because here. So you're saying keep tan here. And this 1 minus tan squared. So that part's right, but you can't cancel part of an expression. This is that's right. That those have to stay together. You could factor it out, but it still won't cancel. Yeah.
Let's say it was a cosine squared at the bottom. Could you move the cosine squared up and it'd be secant squared?
Yeah.
Would it be 1 over secant squared?
No, it would be secant squared. Yep. All right, so now I'm here. Now what? Tangent squared becomes sine squared over cosine squared. And be careful there. Don't forget those squareds. That's what people make a mistake on. Now what? Cancel out the cosines. And sine squared equals sine squared, which was the goal. So that last statement should look like that. You can literally like draw. You don't have to write that sign every single time, but you want to make sure you bring it down.
What would you do if it was cosine times tangent? Times cotangent.
Then it would, well, then it wouldn't simplify to be the same thing. But if it's cosine squared, you're saying, times cotangent, yeah? Then this would be cosine squared times cosine squared over sine. And then you could end up with like cosine to the 4th over sine.
And then for like the end result, you would just multiply.
Well, that does not simplify to be sine squared. So you couldn't.
At the end, you would just bring the sign up, and then you would just leave it at that. Like you couldn't simplify it anymore.
Correct.
Okay. And
Yeah.
it would just turn into cosine.
This, honestly, if it was something like this, it might actually work its way backwards to be like that answer. So you'd have to know to separate out a cosine squared and then change the cosine over sine to cotangent. So I would say more likely this would end up being the question, and that would be the answer instead of the other way around. Yeah.
Could you just divide by tangent squared?
Yeah, so remember we said there's
Cosine squared.
more than one way to do these? You could totally. So you're saying from here, like what if I'm here? What if I have cosine squared x tan squared x equals sine squared x? And you see that you want to move, which is totally cool. Cosine squared x, cosine squared x. Now it's gone from here. I have tan squared x equals, and then sine squared over cosine squared is tan squared. So that would also earn your full credit. Sometimes, like, people would recommend trying not to manipulate both sides of your equation in order to get there. Like, some teachers will actually tell you can't. But there are certain scenarios in which you have no choice. So for me, as long as you get to that end result and the left side equals the right side, and obviously your steps justify it, it doesn't matter. Sophie?
For the one to the left where you did the cosine times cotangent,
Yeah.
you couldn't make the cotangent tangent.
It would have to go to the denominator as tangent. So if it becomes its reciprocal, it moves from top to bottom or bottom to top. So it would be cosine squared x over tan squared x. Like, you could do that. Yeah. Oh, go ahead.
When you're doing the verify question, what would like your answer be?
The work.
That.
So you need all those steps, and then the very last step should be that the left side equals the right side. So assume, like, you cannot skip anything. You cannot leave steps out. You can't do things in your head. This is like writing every step out. Amy? Sure. Sam? You get no credit. Zero. The plan is to not know what you're doing. Yeah. All right, look at 2. How can I start it? So sine squared plus cosine squared is 1. I can make secant 1 over cosine. And then the cosines cancel. And I get 1 over 1, which is 1. Yep.
Can you put secant to the top?
Yep, and it becomes
It still becomes one, but like, can you like flip it?
Yeah, like, so if I bring this to the top,
Yes.
it becomes cosine. So like if you're gonna show that step, you wanna do it exactly that way. Like give me the arrow, and then it would become cosine squared over cosine squared, which is 1. And that's why there's more than one way to do these, because both of those would receive full credit. Yeah. Questions on that one?
Oh, also,
Yeah.
you know how you said you have to like write every step? Do you
Yeah.
have to put like when you're using the Pythagorean?
No.
Like you don't have to write the
No, like this one, I can immediately replace with this. I would say if it's one you have to move around, you might show that work.
subtract.
Mm-hmm. All right. Try 3. What's one way? Make tangent sine over cosine. 1 over cosine, or move it to the top. Move it to the top. So then bring the secant to the top, it becomes cosine. And then cancel out the cosines.
Can you also just like put it side by side and flip it? Like that? Like you just like move it to the side and flip it? Like
Move this to the side,
Like, yeah, because it's.
but make it 1 over, yes. So you can do tan x times 1 over secant x. That's what you're saying?
Yeah.
Yep.
No, like. Oh, yeah.
And then what would you do?
And then you make tangent sine over cosine, and then you make cosine over 1.
So bring that to the top. Yep. That works. All right. How about 4? What's 1 plus cotangent? Cosecant, right? 1 plus cotangent squared equals cosecant squared. So you wouldn't have to like show that work because that is straight up what the actual identity says. Sine squared x times cosecant squared x.
Should the X or whatever.
As long as you have it somewhere, yeah. If it was part of your answer, it has to be part of your answer. Just don't lose your squareds. I've seen that happen. All right, now what? 1 over sine. And then they cancel, and 1 equals 1. Questions on that one? Try out to go by yourself. What'd you do?
Okay, so I did the left side. I did 1 I did actually I did no, I did the right side actually.
Okay.
I did 1 over cosine minus cosine,
Okay.
and then I made the denominators equal, and then I got 1 minus cosine x squared over cosine x.
Okay.
And then after you do it, you can switch 1 minus cosine 2x to sine squared x over cosine x.
Good. Anybody work the left side? Really?
Can you do that again?
Mm-hmm. So she took the right side. Good job, Sophie. She took the right side. She changed secant to 1 over cosine. And that was this step here. And then you know by looking at the left, and usually I would say a goal would be to get rid of 2 fractions anyways. You want to combine them. So in order to combine them, you got to give them a least common denominator. You'd multiply the cosine x over 1 by cosine in the top and the bottom. And you'd end up with 1 over cosine here. 1 over cosine x minus cosine squared x over cosine. And then they have the same denominator, so you can combine them, and you'd get the next step. 1 minus cosine squared x over cosine. And then you'd go to your Pythagorean identities, and sine squared x plus cosine squared x equals 1. So if I move the cosine on the side with the 1, sine squared x equals 1 minus cosine squared x. And so you can replace 1 minus cosine squared x with sine squared x. And then you got the left side. So the left side, if you had like separated it out, you can actually make this, well, you could have done opposite of what Sophie did. You could do 1 minus cosine squared x over cosine x. And then because you want to split these into two fractions, like if you're looking at the right-hand side, you can actually split them into two fractions. They both get cosine as the denominator. So this would be 1 over cosine x minus cosine squared x over cosine x. And then 1 over cosine becomes secant. And then one of these cosines cancel and you get cosine. So that's if you had worked left side to get to the right side, but both would be correct. Yeah. You added cosine x from where? Oh, cosine, like here and here. And then gave it a like denominator. So cosine squared plus sine squared over cosine. And then 1 over cosine is cosecant. Or is secant. Yeah, that works too. Yeah. This is fun. These are fun to grade because I'm like, what did they do? Oh, that was interesting. I didn't see that, but it works. Yeah. Okay, how about this one? Go ahead.
Okay, so for that one, I did the left side.
Okay.
I multiplied it by secant plus.
So like what we did at the beginning of the day, right? So secant x plus tangent. I would say that's a good way if you're stuck and you have no idea how to get a denominator out, that's what you want to do. So multiplying by the opposite. So my numerator becomes secant x plus tan x over, and then this would be secant squared x minus tan squared x if you FOILed it out.
And then the bottom would equal 1 because of the.
So tan squared plus 1 equals secant squared, which means if I move this over here, 1 equals secant squared minus tan squared. So this whole thing becomes 1. And then I get secant x plus tan x equals the other side. Good. Yeah.
Whenever there's like no square, is that the easiest way just to like multiply by 5?
Yeah. If it's a sum. And if they're ones that are partners in your Pythagorean identities. So like if one is with cosine or one is with sine or sine and cosine are together, yes. Or secant and tangent, one and secant, yes. Cosine or cosine and cotangent and cosecant with ones or together, yes. Yeah.
Can you do the right side then, or is that much?
Yeah, no, you could do it. So what'd you do? 1 over cosine?
I got stuck. Yeah, I got 1 over cosine and then tan, I made it as sine over cosine.
Sine over cosine.
Then like 1 plus sine x over cosine.
And then you get stuck though,
Yeah,
right? So then you could multiply by cosine. Replace with 1 minus sine. It gets messy. Cosine, cosine, cosine. I don't know if this is going to make any sense, so hang on. 1 minus sine squared. So cosine, 1 plus sine, over 1 plus sine, 1 minus sine. These cancel. And then you can split that. No, you can't. You'd have to multiply by 1 plus sine. You'd have to go back to your opposite again. No. I don't know if you can get there from what you did. I mean, sadly, it's a good lesson. There's going to be times when you get to a dead end, and I'm sure there is a way there, but you got to try it again. Yeah, so like if you get to a point and you're like, I don't know where to go, try something new. Yeah. Next one, go.
So I did the right side.
Okay.
I mean, had like numbers, so I took the first one, I multiplied by 1 plus sine of x, and then 1 minus sine of x. And then you get, the signs cancel out, so it's just 2 at the top, and then at the bottom it's 1 minus sine squared. And then bottom Pythagorean identity is cosine.
So you have 2, right? Over 1 minus.
2 over 1 minus sine squared.
Yep.
And the bottom is cosine squared because it's Pythagorean identity, and then you just move the cosine up, and it's secant squared, or 2 secant squared.
Good job. Anybody do it differently? Okay. But I'll say it again, like sometimes you have to try everything because sometimes your number 3 might be easier than your number 1. Like it doesn't mean everybody's going to look at them the same way, first of all. And second of all, like that it goes in order of difficulty, because it might be like one that completely stumps you. It's like one of those times where we remember in the early, like maybe semester 1, where you get question 1 and question 1 was hard and you'd freak out and you can't get past it. You got to skip and go back to it, because it could be the last question that's the easiest for you. So you just got to keep trying. All right, we're going to do a couple more. So save 8, because I would say that that's like the one that we just did. And so you can practice that later. What about 9? Yeah.
You can switch tan squared x with 1 equals secant squared.
Good. This is secant squared x. And how about cosine squared x minus 1? Good. So it would be sine squared x plus cosine squared x equals 1. So if cosine has the 1, it means you're subtracting the 1 and moving the sign to the other side. That's where you got to be careful with your positive, negative signs, because this would get replaced with a negative sine squared x. Then secant becomes what? 1 over cosine times negative sine. And this becomes negative sine squared x over cosine squared x. You don't need that step, I would say. You could go straight to negative tangent. But if you write it, obviously it's not wrong. But I wouldn't take off if you didn't write that step. Okay, save 10 because it's like that one. Go to 11. Yep. Yeah. All right, so this is a good one that I would say, like, you could have seen an even odd function built into this one. So if it had said tan of x cosecant of x equals secant of negative x, I would say that's when you could see, this would be an easy one to see a cofunction one on. As soon as you see a negative on an angle, you're going to go to your cofunctions, right? And what happens with secant and then negative x? It goes away, it becomes positive, right? So this gets replaced back with that. So that's an easy, just straight up replacement. Now I've got this, and then I can do what with the left side? Sine of x over cosine of x. 1 over sine of x. Cancels. 1 over cosine x becomes secant. Yeah. I said it could have started this way. Like if I gave you the question that way, know that that's an odd function, or an even odd function, actually. That one's even. So if you go to your odd functions, cosine and secant both get rid of the sign on the trig function. If it was any other one, I would put the negative on the front. Yep.
Would you like rewrite it? Like if it was sine of negative x?
It would be negative sine of x.
But would you like change it before you saw it?
Yeah. So if that said, yeah, so if it said negative on the inside, you would bring it to the outside. And then obviously what would happen? So sine, tangent, cosecant, and cotangent, the negatives would go to the front. Cosine and secant, they go away. So I'm going to just show you one other. So like if this said, here, let's say this said cosecant, this is how you could see pi over 2 minus x. So that's how you would see the cofunctions, okay? I think they're easy to spot because you literally, it's the only time you see pi over 2 minus an angle. So I would go to the cofunctions, and the cofunction that matches cosecant is secant. So this becomes secant of x. So that's how you would see it. That's how you would see it built into those questions. Cosecants would look like that, and then the even and odd would look, cofunctions would look like that, and then the even and odd would have a negative on them. So this one, look at the right side. You should see that there's a tangent on both of those, right? So this goes back to the factoring one. You can take out a tan squared x here, and I'd get secant squared x minus 1. And then that's one of your identities, right? Tan squared plus 1 equals secant squared, which means if I bring the 1 over here, this is just tan squared again. And that's tan to the 4th. Bye, guys.